recording. Okay, and really this is for you guys. So I don't have anything pre-prepared. I'm here to answer whatever questions you may have about the assignments that have been posted. So let me know where you want me to go. And if someone is on the phone, you can go ahead and chime in from there as well.
I'm Candy. Regina, if you want to just work through a problem, that would be very helpful for me to just see it one more time all the way through. One of the
sure.
diversity problems.
Sure, absolutely. Can you see what's going on?
I'm getting there.
Or are you just on the telephone?
I'm just
what? I'm sorry.
Connecting now.
Oh,
I'm
good.
connecting now.
Okay. Okay, let's see. Kathy has said problem number 3 of the exam review. Okay. I'm looking at the exam review. Oh, here we go. Okay. All right. So the exam review, problem number 3, where'd my little pen go? Here we go. So, oh, I need the pen. There we go. Sometimes this is really hard to use. Okay. Given azimuth AB and the angle at B and the angle at C, note the azimuth of AB is from north and angles are to the right. Compute the azimuth from north of line BC and line CD. Okie dokie then. So, let's start with so the azimuth of AB is 345 degrees and change. So we know we're somewhere over here, where that's A angle. What the problem is trying to tell you is that when you sight in on A at B and turn to C, that's what the 149/50/16 is. It's actually the angle at B. I probably should just change the way that's written so that it's a little bit clearer. So A, and then there's B. So what it's telling you is that your angles are to the right. Oh, I drew this in the wrong place. So let's take a look at this, because I think I drew myself into a corner already. So if your angles are, we're okay. Okay, so if your angles are to the right, you would occupy B, you would sight back to A, and you would turn your instrument to the right. How far are you turning to the right? 149/50/16. So if that is roughly 90 and that's roughly 180, you're somewhere over here. And that would be C. Okay? And then this angle here is the 149 and change. Now we occupy C, we sight back to B, and we're turning to the right 311 degrees, which puts us somewhere over here. And this angle there that comes around to there is your 311 degrees and change. So that's what your picture looks like based on the description that you're provided. from north, angles are turned to the right, and now they want the azimuth from north of line BC and the azimuth from north of line CD. So to get that, we have our azimuth of A to B, 345 degrees, 27 minutes, 37 seconds. Okay, we're going to subtract 180 degrees to get our reverse azimuth. And I haven't done the math, so let's see, 37, 27, 5, is that 165? Does that look right? Checking my math here. 5, 8, and 6 is 14. Yeah, I think so. Now that is going to be the azimuth of B to A. So then we add the angle at B, which is our 149, 50, 16. And that gives us 315 degrees, 17 minutes, 53 seconds. That is now the azimuth of BC. To then calculate our next azimuth of C to D, we start here with our azimuth of B to C, but now we need our azimuth of C to B. So we are going to subtract 180 degrees. 53, 17, 135 degrees, that's our azimuth of C to B. We're now going to add the angle at C, which we know to be 311, 16, 09. When you add this up, you're going to get more than 360 when you subtract the 360 back out. Well, I guess we can just do that. Kind of running out of space, but let's see. And I can see that Jonathan just joined us. Okay, so let's see, 9, 10, 11, 2, carry 1, 62, 33, 6, 4, 4. This actually becomes 02, and this becomes 34, 446, minus 360, gives us, write it over here, let's see, that gives us 6, 36 from 44, should hopefully be 8, 86, 3402. And that is now the azimuth of C to D. So there's one answer. Right there's the other one. Okay? Does that make sense, Kathy? Does that help? Okay? New page. So Sandy, you had requested a problem. What would you like? Which sample problems? Are you talking about an azimuth and bearing problem, or are you talking about a traverse problem? Traverse. Okay. I can at least get you started and well through the first traverse problem. And I'm just going to have to skip some of the calculations because, yes, it is a lot of paper and it takes a while. But if we look at, okay, let's look at traverse problem number 1. That happens to be what I have really handy. So the first thing we need to do is balance our angles, right? So we have A, B, C, D. This is really hard to do because you can't put your hand down on the screen. Okay. 111, 36, 03, 66, 49, 23, 111, 44. And the solutions to this and all of these problems will post, the solutions to the azimuth problems and the exam review will post probably tonight at midnight. The traverse problems, I'm still working on typing them up so that you can actually read them. So those probably won't post until tomorrow, sometime tomorrow. But we will get those posted for you as well. I say we because Xanth is sitting here. 69, 50, 30. Okay, so when you add all of these up, you're off by 26 seconds. You come up to 360 degrees, 0 minutes, 26 seconds. 26 seconds does not divide evenly by 4. So I arbitrarily subtracted 6 seconds here, 7 seconds here, 7 seconds here, and 6 seconds here to give you your balanced angles of 111, 35, 57. Now, if you did this a little bit differently, as long as your angles balance, it's not really going to matter. You're still going to come up with answers extremely close to what I'm posting. So don't freak out if yours looks a tiny bit different than mine and you put more error in one spot than another. That's not going to create a problem. So 50, 24. So these are now my balanced angles for A, B, C, and D. Okay? And this does sum to 360 degrees. So that was the first thing we needed to do. The next thing that we need to do after balancing our angles is we need to compute the azimuth and bearing of each side of our traverse. Well, I'm hoping we all know how to do that now. So we have the azimuth. I'm not going to write all these out. I'd be here all day. We have the azimuth of AB, 12 degrees, 47, 22. We can calculate the azimuth of, let's see, we need A to B. We need B to C. B to C is 259 degrees, 36, 38. We need C to D, 191, 21, 1 second. And we need the azimuth of D to A, 81 degrees, 11 minutes, 25 seconds. Okay? Again, if your angles here are slightly different, your azimuths will come up slightly different, meaning you might have 37 seconds instead of 38, depending upon how much error you put to balance the angle at B. So again, as long as when you do your calculations for all your azimuths, you check back in on where you started, you're still good and you're not going to have a problem. We need our distances, which were given in the problem, in order to calculate our latitudes and departures. Okay, I'm not going to write all the distances down. They're on the sheet that you have. To calculate latitude, latitude is the distance of the segment times the cosine of the azimuth. Azimuth. The departure is calculated as the distance of that segment times the sine of the azimuth. Okay? So the latitude for segment AB is equal to 93.08 feet, the distance of segment AB, times the cosine of 12 degrees, 47 minutes, and 22 seconds, which gives you 90.77 feet. The departure for AB is 93.08 feet times the sine of 12 degrees, 47 minutes, and 22 seconds, which gives you 20.61. So far so good? Everybody with me? Okay. So you would continue that process and you will end up with negative 3713, negative 20253. And the more you can put these into tables, the easier it will be to keep track of all the numbers and figure out what you're doing and where your numbers came from. You'll see in my solutions that I do that. I even put the calculations in the table for you because I'm typing it. It makes it much easier to do. And this 198.86. So then what you're going to do is you're going to take the sum of the latitudes and the sum of the departures, whoops, and they should equal to 0, right? Well, they equal 0.03 and negative 0.01. So they're super duper close. We're actually really close to on target here, which is nice. But we still need to force this to be 0. We have to force the traverse to close. So we need to use the, what are we using? We are using the compass rule to make the corrections to your departures and latitudes. So let's see, we're going to use compass rule to correct latitudes and departures. And what does the compass rule say? The compass rule basically says that we're going to take our error and we're going to distribute it proportional to the size of the segment. So basically you're creating a ratio of the distance of the segment to the total perimeter of the traverse, and then your error will be divvied out accordingly. So to make the correction to the latitude of AB, and I know your book doesn't do this, but I add the negative sign so that I don't have to think about it. You're going to take the error, the latitude error, which is 0.03. You're going to divide that by the perimeter of the traverse, which is 586.33. And then you're going to multiply that times, since we're talking about segment AB, the distance of AB, which is 93.08. It's going to give you a correction of negative 0.005. You would then calculate this, the correction of the latitude of B to C in the same fashion. So 0.03 divided by 586.33, that never changes for these, times the distance of B to C, which is 205.91, gives you negative 0.01. The correction to your latitude of C to D, negative 0.004, and the correction of the latitude D to A is negative 0.01. Okay? The negative just tells us that we were over a positive 0.03. We need to bring that back down to a 0. So by putting the negative in front, our answer will always come up with the correct sign in terms of how we apply it. So now let's look at our, so we have segment A to B, B to C, C to D, and D to A. And these are going to be our corrected, oops, there we go, our corrected latitude and departure. So our initial calculation for latitude was 90.77. Our correction for AB is negative 0.005. Take a look at this. Technically, if you add 0.005, 0.01, 0.004, and 0.01, if you add those up, you actually get 0.003. You're going to be just 1/100th off. Okay? So really, you're taking that error and you're distributing it. Well, we really can't work with this 5/100th, so I'm just making the decision to put our third 100th into that category. So to get my corrected latitude for AB, I'm going to take my original latitude, 90.77. So this is going to be 90.77. And now I'm going to add my correction, which is negative, I'm making this 0.01. So I'm going to add my negative 0.01, which will give me, I'm going to move this over here, departure, which gives me a corrected value of 90.76. Okay? 6. That's a 6. There we go. You would do that for each of the corrections. So the corrected latitude for segment B to C would be, here's our initial latitude right there for B to C, 37.13 to negative. So negative 37.13. the value, the correction we need to apply is negative 0.01. So minus 0.01 gives us negative 37.14. Okay? Here we would just have negative 84.43 because we're not really applying the correction there. And then because we added that extra half here, remember I made that decision to round up basically? Yes, John, you do this to all of them. So now for DA, you would have your original latitude of 30.82 minus 0.01, which gives you 30.81. You'll know you've done it correctly because when you sum them again, wow, I'm really screwing up my little sigma sign there, isn't it? There we go, sigma, there we go. You should get 0.00. And you would do the same thing with the departures. So you would start with 20.61, and then you would have to calculate the corrections for your departures. And to calculate them, so the correction to the departure of segment AB would be equal to, here, the error, so negative 0.01, negative 0.01 divided by the perimeter, 586.33. That's a 3. Times the distance of AB. What just happened there? Come back. Times the distance of AB, which we know to be 93.08. So the value of the correction for the departure of A to B is 0.002. Okay? And then you would do the calculation for the correction of the departure of B to C, C to D, and D to A. And when you calculate all of those out, you get plus 0.004 plus 0.001 plus 0.003. Okay, but the reality is you're taking 1/100th and trying to slice it into tiny little pieces, which just really doesn't work very well. So I went ahead when I did it and said that's kind of silly. I'm going to have to keep rounding everything up anyway, and I just took the 1/100th and applied it to the largest segment. So my corrected departures are 20.61, which was the original, negative 202.52. That right there is where I applied that 1/100th error to the largest segment. Whoa, what just happened? Come back. There we go. Sorry. So I applied the error here to the largest segment, minus 16, because the error is so small, it's just too difficult to proportion. And then again, you want to make sure that these sum to 0, which they now do. So these are our corrected departures and latitudes, and we used our compass rule calculation to go ahead and come up with our corrections and apply them to our departure and latitude. So the next step after doing that is to compute your linear error of closure and the precision ratio of your traverse. Make sure I'm at the end here. There we go. Okay, your linear error of closure, E, is equal to the square root of the misclosure of your latitude minus the square root of the, why do I have, I think I wrote that down wrong. This is basically, what this is basically saying is wherever you started, when you came back in to finish, you were a bit off. How far off are you? That's how far off. What we're doing is calculating this connecting piece. So we're looking at our departure and we're looking at our latitude and coming up with that connecting piece. We're just using the Pythagorean theorem. So if you calculate this out, you get 0.032 feet. That tells you the distance between your 2 points. Now your precision ratio tells you how good your traverse is, meaning how accurate your survey was. And that's equal to this linear error divided by the perimeter of your traverse. And it's always expressed as 1 in so many hundreds or thousands of feet. So how do we get that? Well, to get a 1 on top, we divide 0.032 by 0.032. What we do to the top, we must do to the bottom to keep it equal. So it becomes 1 over 18,322, which we would round. You're always going to round to the nearest hundred. So 1 over 18,300 would be our precision ratio, which is really, really awesome. Okay, any questions so far? Are you up with me still? We're still hanging in there? Okay, good. Yay! All right, so we've done that, the linear area of closure and the precision ratio. We did our bounds, departures, and latitudes. We already have that. So our next step is to compute the rectangular coordinates of all of our points. So compute our rectangular coordinates. Okay. Let's see. Our figure looks kind of like this. This is really hard to draw on here. So that's A, B, C, D. So what we want to do is come up with, as if this were on a grid, like this, coordinate system, where this is north and this is east, or this is y, our y direction, and this is our x direction. We want to make sure that this entire figure is in this positive quadrant. We don't want it dropping down here or coming over here. So you want to arbitrarily select a starting point that makes sure that this entire figure remains in this quadrant. So I started out with, here's my stations, here's my northern coordinate. Remember, that's y. And our eastern coordinate, which is a little backwards to math where we usually list x, y. We always list y, x because we always list north first. So D, A, B, C, D. I started out with D in the bottom left corner-ish, and I assumed a coordinate of 1,000, 1,000. So here I'm saying is 1,000, 1,000 is our coordinate. That will make sure that this entire figure remains in the upper quadrant and remains positive. Now the way we calculate coordinates, remember that we calculated all of these balanced departures and latitudes, right? So if we're located here and we want to go to A, how far over do we go? Well, we go over our balanced departure and we go up the balanced latitude. So looking at those numbers, we go over here to the east, our balanced departure of 198.86, and we go up 30.81 feet. So then the coordinates of A are 1,030.81, 1,198.86. Now we go from A to B. So again, we're heading in the positive direction for our easting and our northing. How far over do we go? We go 90.76, our balanced latitude, and 20.61, our balanced departure, giving us coordinates for B, 11:21:57, 12:19:47. Now we're going to go from B to C. So we're heading west and south. How far west are we heading? Minus 202.52 minus 37.14. And again, these are just your balanced departures and latitudes. So the coordinates at C are 1084.43 and 1016.95. Now we're going to go back from C to D. Even though we know that D is 1,000, because that's what we assigned it to be and assumed it to be, you better make sure that you add to that to make sure that you didn't have an error. And if you look at our balanced departures and latitudes, we have minus 84.43 and minus 16.95. So we check back in, and now we have the coordinate values. Oops, stay put. We now have our coordinates for each of our stations right here. There we go. Okay. So the last thing we need to do now is calculate the area using our coordinate values. And there's a really handy way of doing that. Here's the handy way of doing that. Create yourself a little table. This works actually really well in Excel. You need your point. You need your x coordinate, your y coordinate. You need plus x times y minus y times x. Just be careful when you put your points in here of two things. First thing is you have to come back to where you started. The second thing is remember that your x coordinate is your easting and your y coordinate is your northing. So they're listed backwards to the way that surveyors list them. So if we go back, our northing coordinate for D is 1,000. Our easting coordinate is 1,000. Our northing coordinate for A is 1030.81. So 1030.81, and our easting is 1198. Oops, went the wrong way. 1198.86. Okay, so you would just write them all in this way. I'm going to go ahead and try to put them in here real quick. So we have 12, 19, 47. C is 10, 16, 95. And we're back to D again at 1,000. And it is really important that you include that. 1030, so 11, 21, 57, 10, 84, 43, and back to 1,000. So here's what you do. Come back. Okay, Jonathan, I'm not sure what you mean by come back. Oh, I'm sorry. Yeah, I was adjusting the temperature in my office really quick. I'm sorry. Okay, so let me change colors here because it'll make this much, much clearer. Come on, color. There we go. Whoops. So let's use this blue. Okay. So plus XY, you're going to take 1,000 and you're going to multiply it times 10, 30, 81. And you're going to get 1,030,810. You're going to take 1198.86. You're going to multiply it times 1121.57. You're going to multiply 1219 times 1084 and 1016.95 times 1,000. And then you're going to write them all down. So you should get 605, 1322429, and 1016950. Okay? Those are your plus X times Y. You've got D of X times Y of A, you've got A of X times Y of B, you've got B of X times Y of C, and you've got C of X times Y of D. Then, I'm going to change the color of the pen here again to red. Then you're going to take 1,000 and multiply it times 1198, 1030 times 1219, 1121 times 1016, and the 1084 times 1,000. And you can record those over here. That's going to give you 119,860, assuming all my math's right. 1257041. 1140. 580 1084 430. Okay? You're going to add up this column, you're going to add up this column. So this gives you 4680912. Go back to my blue color, there it goes. And this column is going to give you 4714795. The way the formula is written, you take D sub X times Y sub A and X sub A times Y sub B, etc. And then you subtract Y sub D times X sub A and Y sub B times Y sub A times X sub B, etc. And you multiply all one way, you multiply all the other way, and then you take the difference between them. Now, you're just getting the difference, and remember that you're talking about area. So sometimes this difference, when you subtract it, may come up to be a negative number. Ignore that. You can't have negative space, right? So it just has to do with the way the numbers were multiplied. So now we're going to go ahead and go back to our black. And we're now going to take the difference between these two numbers. So we're going to take 4,714,795 minus 4,680,912, and that gives you a total of 33,882. But remember that this equation is equal to 2 times the area is equal to the difference between these two numbers. So we need to divide this by 2, which gives us 16,941 square feet. That's the area of this traverse. But you would never represent things in square feet, so we need to convert this to acres, which would be 1 acre over 43,560 square feet, which is going to give us 0.4 acres. Okay, Kathy has a question. This is the alternate to what you just did, right? Alternate. I'm sorry, Kathy, I'm not understanding your question. What you mean by alternate? I'm basically taking the formula for calculating area, and instead of, that's part of the original formula. When you look at the formula to calculate area, 2 times area is equal to x sub a times y sub b plus x sub b times y sub c plus x sub c times y sub d plus x sub d times y sub a. This is assuming a 4-sided figure. You would just keep going if you had more. Minus y sub a times x sub b minus y sub b times x sub c minus y sub c times xd minus y sub d times x sub a. That's the actual formula for the area of a 4-sided figure with stations A, B, C, and D. Yes, the cross multiplication is just a quick and easy way of calculating all of this out without having to sit here and try to plug in all these numbers and then type them all in. And it works really well when you have a much larger figure, especially since you can just put all of those coordinates into an Excel spreadsheet and have them multiply it out for you, right? Because if this had 5, 6, 7 sides, we'd have additional terms here, right? We'd have x sub e times, you know, y sub whatever as we went around. So all I did is this formula right here, which is our formula for area, is just represented here. So here's all of my x sub a, x sub b, c, d, right? My y coordinates, x sub d times y sub a, x sub d times y sub a, x sub a times y sub b. Here's my x sub a times y sub b. So these are all of the plus xy coordinate, pieces, and these here represent all of the minus y. Oops, wrong direction. These here are represented here in this column by the minus y times x. So we have yd times xa. There's our yd xa. So it's just an easier way to try to remember and then calculate out all of this information. So again, 2 times the area is equal to all of these, which are all of our pluses, minus all of these, which are all the minus y times x. So if we add them all up, we then just put a little minus sign in the middle and subtract the difference. So 2 times the area is equal to all of this added together minus all of that added together. It's the same exact formula. We're just writing it out a little bit differently so that it's easier to do mathematically. So 2 times the area is equal to this minus this, which is the 33,882. but it's 2 times the area. So to get the actual area, we need to divide that by 2. These are all square feet, right? Because these coordinates are all in feet. So now we have our square footage, and we convert it to acres. So what we did here on this slide is exactly this formula, just written out differently so that it's easier to multiply, easier to plug in. Okay? Whew. Any questions on this part so far? We are actually just about out of time. It's 4:50. So I want to make sure I try to address as many questions as I can. And if you would like to go over more problems later this week, let me know. We can either set up another time to do the CCC Confer, or you guys are free to call me or come by or email me individually as well. And the solutions, as I said earlier, to the azimuths and the exam review will post at, I think, midnight tonight. And I'll get these traverse calculations posted hopefully tomorrow. So you'll have all those as well. The distance between C and A. Okay, let's see. So if we now have coordinate values for each of these points, right? A coordinate is 1030, 81, 1198, 86. So the coordinate here is 1198, 86. That's our easting coordinate. And our northing coordinate is 1030, 81. 1030, 81. We also know our C coordinates, our station for C, which is 1016, 95. 1016, 95. And the northing is 1084, 43. 1084, 43. And we now want to know the distance from C to A, or from A to C, right? Well, if we know the coordinate value here and we know the coordinate value here, isn't this just another right triangle? And isn't the distance from here to here simply the change in our x coordinates, which would be 1198, 86 minus 1016, 95, which equals 1198, 86 minus 1016, 95, 181, 91. And then, isn't the distance from here to here just the change in our y coordinate, or our northing coordinates, which would be 1084, 43 minus 1030, 81. By the way, it doesn't matter which order you subtract them. Even if you end up with negative numbers, it makes no difference. All we're looking for is the difference between the 2 points. So let's see, 1084, 43 minus 1030, 81 gives us 53, 62. So if we know that this distance from here to here is 181, 91, and the distance from here to here is 53, 62, can't we calculate C to A? Yes, Pythagorean theorem. So the distance from C to A is equal to the square root of 181, 91 squared minus, no, plus, right? Wow, this week's been pretty bad. Yeah, plus a squared plus b squared equals c squared. So c is equal to, right, plus 5362 squared. So let's see here. Enter squared. I need a new slide. Here we go. So we're going to get the square root of 330912481 plus 5362 squared to 8751044. So that's plus that, and then take the square root. So the distance from C to A is equal to 189.65 feet. Make sense? Okay, we are pretty much so out of time, and I have actually someone to run off to, otherwise I'd stick around. But I would be happy to do this again later this week, or again, if any of you individually still have questions and need some more help with this, please by all means let me know, and we will make it happen so that you all are well prepared for Friday. Any other questions or comments at this point? Did this help? Was this helpful? Okay, and this, by the way, was what we were working on in the lab that you were doing the last time we met. This was the process that you were to go through with your data from the lab. Yes, Sandy, yes. You would use the inverse tangent as change in x over change in y to find the azimuth of A to C, or the azimuth of C to A. Just pay attention to what you get and look at your diagram to see that it makes sense for the way that you calculated it, right? That it fits in with your diagram. Anything else? Let's see, I want to make sure I figure everybody who's here. Hold on. So I've got John here, Jonathan, Josh, Kathy, Michelle, and Sandy. Okay. So somebody raised their hand. Yes, Jonathan. You didn't get credit for the last session. Okay. Oh, I don't know that I've posted or updated the session numbers, the session data. So I will make sure I do that before Friday of this week and post it in Blackboard with the updated information, and then take a look at it and let me know if I've missed everybody. The only other thing is, if you were only on the telephone and you didn't show up here in the room, I may not have checked you off, because I can't, unless you speak up or say, hey, I'm here, I'm only looking at those that are appearing here as participants in CCC Confer. And if you're only on the telephone, then I don't see you. So, but let me go ahead and update all the live session information and get that posted, and then let me know if I'm still missing anybody. Okay? It looks like, according to the weather forecast, that it's going to be kind of cold and possibly rainy on Friday, so please dress appropriately. We will be outside for part of the lab. We do have a demonstration coming in from Hall and Foreman. In fact, I'm really excited because one of our graduates is coming to do part of the demonstration. And then you will have time to practice your lab, prepare for your lab final. And the handouts are already posted in Blackboard. And then after all of that and a break for lunch, we will have your second exam. But please, again, come dressed appropriately. It looks like it might be kind of a cold and wet and rainy day again. So, awesome. Thank you, guys. I'm going to stop the recording